Geometry review for exam 1. Exercise 1. This first example is of triangle inequalities. Here they are giving us the lengths of 3 different sides, and we just need to order the angles. Well, one thing I'm going to do when I have the square root of 22 and the square root of 29, I could put those in the calculator and give a decimal approximation, or I could say that 5 is the same as the square root of 25. That makes it a bit easier for me to order these sides. So I'm going to put 1 notch here at the square root of 22 because that's going to be my smallest side. The square root of 25 will be my middle, and the square root of 29 will be my longest. So now I could say, from working from right to left, that side KB is my longest side, which is greater than side BG, which is my middle side, which will be greater than KG, which is my shortest side. When I write out the order of the sides, it makes it really easy to understand the idea of opposite angle, because this triangle has 3 letters, K, B, and G. So when I look at a side KB, I say, what letter's missing? And the letter that's missing is G. That means G is also my largest angle, which will be greater than, I see side BG, the missing letter is K. That means K is opposite side BG. And if KG is my shortest side, then the angle opposite is the letter that's missing, which is B. This question is, what is the largest angle? And the largest angle clearly is angle G. I also could have done that right on my triangle. If this is my 3-pronged side, then opposite is going to be my 3, right? See how it's opposite there? If this is my shortest side, over here with 1 notch, I can go opposite here, and that's my smallest angle. Now, exercise 2 is one that we're doing in the opposite direction. Here they're giving me 2 angles, and they want to know something about the sides. So whenever they give me 2 angles of a triangle, I'm going to make a little table. If they give me the name of the triangle, I'll write it out. Angle A, angle B, and angle C. And here they're giving me the measure of angle A is 58 degrees, and the measure of angle B is 64 degrees. So before I do anything here, I definitely need to know that last angle. So I'm going to remember that the sum of the 3 angles of a triangle is 180 degrees. So I'm going to take some of my scrap here, 64 plus 58, and see that that's equal to 122. I'm going to subtract 122 from 180, and that's going to give me 58 degrees. Oh, look at that. So now that I know all 3 of my angles, it'll be easier for me to figure out the order of the sides. Well, clearly here I have angle B is my largest angle, but then A and C are tied. So I'm just going to put whichever one I want here, angle A. You know, angle B is greater than angle A, which is equal to angle C. So my inequality also has an equality here. Well, I'm going to use the same idea as the sides that are opposite. So the 2 letters that are missing here for angle B are AC. That means AC would have to be my longest side because it's opposite the largest angle. And opposite A will be what's missing, which is BC, which is going to be equal to side AB. So here we have our inequality and equality, and I could very quickly see that C says AB is equal to BC. Because as we can also do with this problem is classify this triangle. Well, if there's 2 angles that are the same, there's 2 sides that are the same, which makes it isosceles. And if the largest angle is 64 degrees, which is still an acute angle, it makes it an acute triangle. This is an isosceles acute triangle. Questions 3, 4, and 5 have to do with triangle constraints, or the third side rule. Question 3 here actually puts the third side rule forward by saying 2 sides of a triangle are 3 and 7. The lengths of the third side must be greater than blank and less than blank. Well, when I introduced the third side rule, I said, well, quite simply, take any 2 sides. Here, they're only giving us 2 sides. I'm going to take 7 and 3, and I'm going to put 7 on 3 over 3 twice. On the left side over here, I'm going to subtract it. And on the right side here, I'm going to add it. Remembering that the third side, which I'll represent with x here, has to be less than the sum and greater than the difference. It cannot be those numbers. It's not greater than or less than or equal to. It's actually less than 10, so 9.999 would be fine, and it's actually greater than 4, so 4.01 would be fine, but not those numbers. So now we can go back. The length of this third side must be greater than 4 and less than 10. Question 4 is a very common regions question. It's saying, can 7, 5, and 6 be the sides of a triangle? The regions question would probably say, justify your work. Well, in this case, I like to take the 2 smaller sides. So I'm going to take 5 and 6. I'm going to put 6 over 5 twice. And on the left side, I'm going to do the difference, which is 1. And on the right side, I'm going to do the sum, which is 11. And I'm going to remember that the third side, x, needs to be less than the sum and greater than the difference. So now I'm going to take the side that I didn't consider, which was 7, and ask myself, does 7 fit between 1 and 11? And the answer is clearly yes. And justification is the work. So you could see it right there. And finally, question number 5. In triangle PQR, PQ is 2 and QR is 4. Find all possible values for PR. So once again, it's the same exact question, just put in a different manner. So I'm going to take the 2 sides that they've given me. I'm going to put 4 over 2 and 4 over 2. Instead of using x in this case, I'm going to use what they're asking me to find, the values, the possible values of the third side, which is PR. So I'm going to put PR here in the middle. I'm going to subtract and add. 4 minus 2 is 2. So PR has to be greater than 2. And 4 plus 2 is 6 and less than 6. There's my answer. Next topic on the test is triangle classification. Please remember, we cannot classify a triangle until we either know all 3 angles or all 3 sides. So here's a problem that states, number 6, if the angles of a triangle are represented by x degrees, a lot of people miss that one, 3x plus 20 degrees, and 6x degrees, the triangle must be ... Well, whenever they give me either 2 angles and there's 1 missing, or they give me 3 representations, I'm going to make a little table. Here they're not really giving me the name of the triangle, so I'll leave the first column blank. But one of the angles is x degrees. The next one is 3x plus 20. And the last one is 6x. In order to solve for x and eventually be able to substitute that x in and know these angles, I have to know something that's true about all 3 angles of a triangle. We all know that the 3 angles of a triangle sum to 180 degrees. So I'm going to add these up. I'm going to add them up down here first. So x, 1x plus 3x plus 6x is 10x. There's only a 20 there, so that's going to come down. So I'm going to say that 10x plus 20 must be equal to 180 degrees. Take down my 10x, take down my 180. The 20 is going to fly to the other side and become a negative. My 10x is going to be equal to 160. I'm going to divide by 10 on both sides and get my x is equal to 16. Now, that's only part 1 of this problem. Again, I can't classify this triangle until I know what all 3 angles are. So now I'm going to go and substitute them back into the representations. to figure out what each one is. The first one is x, which is 16 degrees. The second angle is going to be 3 times 16, which is 48, plus 20, which will be 68 degrees. Once you know 2, you can just add them up and subtract it from 180, or you can just multiply 6 times 16, which is going to be 96 degrees. So now that I know all 3 angles, I am ready to classify. I see that none of the angles are the same, which means none of the sides are the same, which means it is a scalene triangle. And the largest angle is 96 degrees. That's an obtuse angle, which makes this also an obtuse triangle. This is a scalene obtuse triangle. I look at my choices. The only choice of the 2 is obtuse. Question number 7 is kind of a combination between classification and constraints as well. It says, which one of the following numbers could represent the lengths of the sides of an isosceles triangle? Well, we all know that an isosceles triangle, can remember from the 2 S's, that an isosceles is a triangle that has 2 sides of exactly the same length. Well, with that said, to be a good test taker, we would eliminate A, because 5, 10, and 15 would be well, can't even be a triangle, but it would be scalene because they're all different. Same with the 3, 4, 5, which would leave C and D as the 2 possibilities, because both of those have 2 sides that are the same. However, when we analyze the 1, 1, 3, for example, if I put 1 over 1 twice and did my third side rule and I subtracted and added, I would find that that third side would have to be greater than 0, of course, but less than 2. And 3 does not fit in between that. So while C at first glance might be an isosceles triangle, from a deeper study, we find that it cannot be a triangle. So we need to eliminate C, and which leaves D as our answer. Now, just to double check that D is a good working triangle, we could do the third side rule for that as well. I'll put 6 over 6. I'll just pick the first 2. 6 minus 6 is 0. 6 plus 6 is 12. That third side needs to be between 0 and 12, and 5 certainly is between the 2. So yes, that double checks as a triangle and an isosceles triangle. Two parallel lines and a transversal. Okay, we arrive at the last topic that will be on this test, and let's look at number 8. In the accompanying diagram, parallel lines L and M are cut by transversal T. And as you could see, they put numbers in to help us out with the angles names here. So they show me angle 1 and angle 2. And which statement about angles 1 and 2 must be true? Well, the same way that we made the AA, AA, BB, BB map, we can do that with the numbers as well. You know, if that is angle 1 has whatever amount of degrees, I can go to the vertical angle and say, well, this is also going to be whatever angle 1 is. And just by using the idea of alternate interior or corresponding, if those 2 are 1, this will be angle 1 and this will be angle 1. And now we could do the same thing with angle 2. Well, if that's angle 2, then this is angle 2 because those are vertical angles. And because up here, this is a corresponding angle, and that right here is another vertical angle. So all of those angles, the acute angles as they appear, that have a 1 on them are the same. All of the angles that have the number 2 in them are also the same as each other. But if you end up with a 1 and a 2, as we can see right up here on the top here, those are linear pairs. And linear pairs are supplementary. So we could easily come down here and conclude that an angle 1 is a supplement to angle 2. Supplement is just a fancy word that means the angle that completes 180 to another angle when you're adding them, right? Supplement sounds like supplementary. Angle 1 is a supplement to angle 2 because when you add them together, angle 1 plus angle 2, they equal 180 degrees. Come down here to question 9, another illustration. that if you know one angle, you know all of the angles. You know, if you want, you could use that map. You could create a little map when you get your test and put the A and the A and the A and the A, and then put the B and the B and the B and the B. And remember, if you have two angles that are in the A position, they're going to be equal to each other. We'll set them equal to each other. If you have two angles that are in the B position, they're also equal to each other. But if you have an A and a B, for whatever reason, they're going to be supplementary. We're going to add them to each other and set it equal to 180. Well, here they're giving us one angle. They're telling us the measure of angle 1 is 110 degrees. I'm just going to put it right in there because this is a multiple choice question. I can mark this up however I like. I'm just going to write a 110 here. Now, that in my map up here that I made is kind of in the A position. So all of the other angles that are in the A position are also going to be 110 degrees. So I can put 110 there because those angles are vertical. If we go do the little zigzag, that means angle 5 is either the alternate interior of the one here or the corresponding to the other one, right? It's also going to be 110 degrees, and so is angle 8. Now, I could do this in my head, and I'm sure you can too, but if you take 180 and you subtract 110, you get 70 degrees. So all of those angles in the B position are going to be 70 degrees. 70, 70, 70, and 70. So you can see once you know one angle, you know them all when you're dealing quite simply with two parallel lines and a transversal. So if angle 1 is 110 degrees, I could see that angle 7 was down here. That's going to be 70 degrees because they are supplementary. And technically speaking, if we want to know the exact name of the relationship between angle 1 and angle 7, those would be same side exterior angles. Exterior because they're kind of outside the make pretend rectangle there, but on the same side of the transversal. Same side exterior angles are supplementary. All right, let's go up to number 10. Number 10 I put on here because to show you, well, while sometimes it's easy to name angles with little 1s and little a's, you do need to be able to find angles based on three-point system, right? So here you could see they have line AB, line CD. In the company diagram, parallel lines AB and CD are cut by transversal EF at P and Q. So here we're dealing with a lot of points. So which of the following statements must always be true? A, the measure of angle APE is equal to the measure of CQF. Well, one system that I like to use when I have three-letter names of angles is to kind of just follow the dots. So angle APE is an angle that comes from A to P towards E. So you can see, well, there's kind of that angle, angle APE. And angle CQF would be an angle that goes from C to Q to F down here. Well, if you just kind of observe those, you might notice that one of those is clearly obtuse, angle APE, and that angle CQF is clearly acute. You can also, you might want to do your AABB. That's fine. And, put an A, and then put your B's in. B, 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 B. And you can see that angle APE is represented with an A. Angle CQF is represented with a B. So they're clearly not equal to each other. But then we get to the next one, and that should kind of light up a light bulb. That angle APE, the same two angles that we just drew, add to 180. Well, if you've been paying attention, we remember that all the A's are equal to all the A's and all the B's are equal to all the B's. But if you have an A and a B, they're going to be supplementary. So we get right to our answer right there. Okay. Last regular question before the constructions, number 11. In the company diagram, line ABC, the measure of angle DBC is 138 degrees. I can see they put that angle in there for me, angle DBC. And AE is parallel to DB. When it's parallel, I'm going to put my little arrows. There's an arrow, and there's an arrow. Now, one little hint that might be helpful to some of you is that when they give you parallel lines, but they're not very long, you can always put your straight edge down on two lines that are parallel and extend them. I'm going to extend that line, and I'm going to extend that line. And now it kind of starts looking like two parallel lines and a transversal. It's just rotated. The question here is find the measure of angle EAB. So I'll do my connect the dot rule to try to find from E to A towards B. Oh, so this is kind of the angle. Put a little X there. That's what we're looking for. Okay. Well, just doing what we just finished doing over here on number 9. Remember, if you know one angle, you know them all if you have two parallel lines and a transversal. So, yeah, I could just know that some of these angles are going to be exactly the same, like the vertical angle over here. This is going to be 138. And the ones next to it are going to be linear pairs, meaning they're supplementary to the 138. So on my scrap paper, I'll say 180 minus 138. And that's going to be, what, 42 degrees? That means this angle up here is going to be 42, and this one is also going to be 42. Well, now there's a lot of ways we can get to the angle that we're looking for, so I'll just choose one. How about the zigzag? Boom, 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 or zigzag, right? This angle and this angle zigzagged between two parallel lines and a transversal, making them alternate interior angles. Alternate interior angles are congruent. So the measure of angle EAB will also be 42 degrees. All right. That leaves us just a couple constructions. The few constructions that are going to be mandatory on your exam, I'm just going to do those here on the review video, and the bonus ones we'll just do in class. So here we go. Number 12, bisect a line segment. Bisecting a line segment is not very difficult. When we're bisecting a line segment, there's a bunch of constructions that have different names that all do pretty much the same exact thing. Whether it's bisect a line segment, or find the midpoint of a line segment, or drawing the perpendicular bisector to a line segment, they're all done in exactly the same way. We begin with our compass on one of the endpoints of the segment we're going to bisect. And basically, all we're going to have are two congruent circles. However, these circles, when you're deciding how big to make the circle, what the radius is going to be, it must be longer than half the distance. So I open up my compass to an obvious amount, which is more than halfway towards B. And now I'm going to construct circle A and circle B. They're called circle A and circle B because circles are named by the point that is in the center. So this right here is circle A. And then keeping my compass exactly the same open, I'm going to move it over to B and draw exactly the same size circle. As you could see, you have two circles that intersect at two different points. We always need to have 2 points to put our straight edge down and draw a line. So we have a point up here and a point down here. So if you were going to draw the actual line, that is absolutely fine. So we're going to connect these points. I'm going to fix it on a smartboard right there. And it's also okay to name that point. I like to call it M since it's exactly in the middle. And now we can also know that there are certain equations that are true. For example, AM would be equal to MB. We can even put a little notch there, a little notch there. Now, bisecting an angle is a different idea, right? Bisecting a line segment is just saying a line segment has a certain length and we're cutting it in half. It's a very simple thing to imagine. Bisecting an angle is a little bit different. For example, if we look at this angle in number 13, that angle has a certain amount of degrees. I could find out what that is, even though it's not necessary, but I'll show you just to get an idea. I'm going to bring down my protractor, and I'm going to put the upside down T right on the vertex of the angle, and I'm going to rotate one of the rays to 0, and then I can just kind of open this up to the other ray, and then hit this little button, and we can see that that angle is actually a 72-degree angle, right? So the idea of bisecting an angle is really just creating another ray that's going to go right down the middle of that angle, that's going to cut that 72-degree angle into 72 divided by 2 36-degree angles. All right, so how do we go about this? Well, doing an acute angle is a little bit easier than an obtuse, so I'm going to put an acute angle on your exam. So I'm going to put the pointer on the vertex of my angle, and just make sure that my compass is open to an amount that when I draw an arc, it's going to intersect both rays. If one of the rays is too short, you can just extend it with your straight edge. It's always okay to extend lines with your straight edge. So I'm going to draw my first arc right there. And as you could see, that arc intersected the rays at 2 separate points. So now I'm just going to bring the pointer to one of them. And because it's an acute angle, I don't need to open or close the compass. I'm going to keep it exactly the same. And I'm going to put another arc right out here in the middle somewhere. And then go to the other point of intersection and intersect that arc that I just made. When you bisect an angle, it should look something like this when you're finished with your arcs. If you imagine the line, it should look as if it's going down the center of your angle, and then you just put your straight edge on the vertex of on vertex B here, and go right through the point of intersection. And now we created 2 angles that should be exactly the same. This one and this one, right? The angle that's right here, the angle that's right there. Those should be exactly the same. Remember, you're graded by the marks that you make with your compass, so never erase them. And the last mandatory construction will be the equilateral triangle, but there's 2 different types. So one of them is just the equilateral triangle where they're giving you, say, in this case, one of the sides. Well, an equilateral triangle, as we know, means a triangle with 3 congruent sides. So if they're giving me one of the sides, I'm going to put my compass down and measure that exact side, and that's side AB. We really only need one more point here. We need to find where C is, right? So we can connect A to C and B to C. So once I have A, B measured, I'm going to keep the pointer on A and draw a nice long arc. And keeping that compass at the exact same radius, I'm going to move the pointer over to B and intersect the arc that I just made. Where they intersect is going to be point C. And now I'm going to put my straight edge down and connect A, C, and C to B. Voila. And now you can mark this up in a number of ways. Once you know you have an equilateral triangle, you have 3 sides that are exactly the same. But you also have just constructed 3 congruent angles. And if the sum of the 3 angles is 180 and you divide that by 3, you've also constructed 3 60-degree angles. Remember, an equilateral triangle is also equal angular. Okay, and last but not least, we're going to inscribe an equilateral triangle into circle O. Well, we've done this in a couple different ways, but I'm going to take you to the most direct. So if they give you a circle in which you need to inscribe a triangle, you need to remember that means that if we made, for example, triangle ABC, A, B, and C all need to be points on the circle, right? That's what inscribing a triangle means, that it's the biggest possible triangle we can make inside that circle. So all 3 corners need to be on the circle. Well, in order to do this, we need to know the radius on our compass. So I'm going to put the pointer at the center and open my compass to any point on the circle and lock in the radius of that circle. Once you have the radius, lock it in because we're going to need it for another arc. We're going to move the pointer to anywhere you want, actually, on the circle. I'm going to put it right there. And once you find a point and you put that pointer on the circle, you're going to make another circle, which is exactly the same. And you know you're doing a good job if that circle goes right through the center of the original circle. Great. Now, as you could see, that creates 2 points of intersection. So I'm going to mark up those points of intersection. There's one right here, and there's one right here. Believe it or not, those are 2 points of our triangle. I'm going to call this one A and this one B. And if those are 2 points on the triangle, that means if I connected them with my straight edge, that's one of the sides of my triangle, A, B. So now that I know one of the sides of my triangle, I'm going to measure it with my compass. I'm going to put the pointer on A, and I'm going to open it to B, and I'm going to keep the pointer on, flip this around here, I'm going to keep the pointer on A and measure the distance to B, which is the side of my equilateral triangle, and it's going to keep the pointer on A and kind of rotate my compass around, and when it gets near the circle, I'm going to start drawing and just intersect the circle right there, and that is my point C. And now the final step is to put my straight edge down and connect A to C and C to B. And there we have inscribed an equilateral triangle into a circle. And that concludes the review for exam number 1.